Hello viewers, this is Mahmoud, and in this video I am going to solve first order differential equation using an integrating factor. So here we have differential equation with this initial condition. So the problem with this initial condition is what we call an initial value problem. So you can see the differential equation is clearly a first order linear differential equation. So first I'm going to write this differential equation into an standard form by dividing each side by x minus 3. So here we have dividing both sides by x minus 3. So here we have dy over dx plus, when we divide the second term, so that would become 6 upon x minus 3 into y is equal, and the right hand side of the equation would become sine x divided by x minus 3 to the power 5. Okay, now we have to compare this differential equation with the standard linear differential equation. So the standard linear differential equation is dy over dx plus p of x into y is equal q of x. Okay, so you have to compare. So we have here 6 divided by x minus 3 is basically our p of x, and on the right hand side this is the function of x, so this is what we call q of x. Okay, so here we have our p of x is equal 6 divided by x minus 3, and our q of x is equal sine x divided by x minus 3 to the power 5. Is it okay? Now here we have we are introducing the integrating factor, and you know that, so the integrating factor is basically if, that is just a notation for integrating factor, that is equal e to the power integral p of x and dx. Okay, so here we have e to the power integral, what is my p of x? So p of x is going to be 6 divided by x minus 3. So that is 6 divided by x minus 3 into dx. Okay, so now the integral of 6 divided by x minus 3, 6 is a constant, so that will come out from the integral, so that would become 1 divided by x minus 3 into dx. Okay, so the integrating factor is equal e to the power 6, and you know that here we can use the integral property, that is, if we have the derivative of the denominator present in the numerator, so we will take the natural log of the denominator, so it would become the natural log of the denominator, that is x minus 3. Okay, here we are going to use the log property, and you know that the property is, if we have n log m, okay, let me write the natural log m, so this can be written as the natural log of m to the power n. Okay, so here we have, this is going to be, the integrating factor is equal e raised to the power natural log of x minus 3 to the power 6. Okay, so now here we have e and log, both are inverses, so we get x minus 3 to the power 6. Got it? So our integrating factor is basically x minus 3 to the power 6. Now we have to multiply this integrating factor with this equation, with the standard equation, this one. Let me call this equation 1. Okay, so here multiplying both sides of 1 by the integrating factor, that is x minus 3 to the power 6. Okay, so equation 1 implies that on the left side when we multiply, so it would become x minus 3 to the power 6 and dy over dx, and then plus 6 times x minus 3 to the power 5 into y is equal, and on the right side when we multiply and simplify it, so it would become x minus 3 into sine x. Okay, is it clear? Now on the left side of this equation, after the multiplying the integrating factor, it would be just the derivative of the dependent variable and the integrating factor. That is, the dependent variable is y and the integrating factor is that is x minus 3 to the power 6. So it would become just the derivative of this dependent variable y and the integrating factor. Okay, if you apply this with respect to x, you will get the same result. Okay, you can use the product rule definitely. Okay, and on the left side, on the right side, it would become x minus 3 into sine of x. Okay, now the next is you have to integrate. Okay, now we are going to integrate with respect to x. Okay, so it would become d over dx of y into x minus 3 to the power 6 to dx is equal the integral x minus 3 sine x into dx. Okay, so on the left side, is derivative and integral both are inverses, so we get only y x minus 3 to the power 6 is equal, and on the right side we will use the integrating by parts. Okay, so this will be my first function. Okay, because it is algebraic and the trigonometry, that is the sine, so it would become my second function. So we will use the integrating by parts. So first, integrating by parts says you have to skip the first one, that is you have to write the first one as it is, and you have to take the integral of the second one. Okay, that is the integral of the second one, that is sine x dx, then minus whole integral. You have to take the derivative of the first one, so that is d over dx of x minus 3, and you have to take the integral of the second one. Okay, that is sine x dx. Okay, just let me write here, that is sine x and dx, and here we have dx. Okay, because this is the whole integral. Now here we have y into x minus 3 to the power 6 is equal x minus 3, and you know that the integral of sine x is basically minus cos x. Okay, and minus integral derivative of first, the derivative of x minus 3, that is going to be 1, and the integral of sine x is again minus cos x into dx. Okay, so here we have y into x minus 3 to the power 6 is equal, here we have minus x minus 3 times cos x, and here we have this minus, and the outside minus would become positive, and integral cos x dx. Okay, so y into x minus 3 whole power 6 is equal minus x minus 3 times cos x, and the integral of cos x is going to be sine x, so that is plus sine x, and then plus you have to put the constant of integration. Is it okay? Now that's good. Now this is basically the general solution. Okay, this is what we call the general solution. So we need a particular solution because of, we have initial condition as well. So we will put the initial condition in this general solution. So we will get the particular solution. Okay. So what we have to do next? So here we have, the initial condition is what? Y of 0 equal 1 divided by 8 1. It means that is x is 0 and y is 1 divided by 8 1. So you have to put in this general solution. Okay, let me call this is my equation number 2. Okay, put in 2. So 2 implies that, 2 implies that what is my y? So that is 1 divided by 8 1 times x minus 3. So it would become 0 minus 3 whole power 6, and then equal negative sign, again 0 minus 3 and cos of 0, and then plus sine of 0, and then plus c. Okay, now we have to simplify this. So 0 minus 3 is minus 3, and you have to take the power, that is power of 6. So minus 3 to the power 6 is going to be 729. So it is going to be 729 upon 81 is equal, here we have minus plus 3, and that cos 0 is 1 and sine 0 is 0 plus c. So when we divide this 729 by 81, so it would become 9. Okay, so this is 9. We have to shift this 3 on the other side, so it would become minus 3 is equal to c. So the value of constant of integration would become 6. Okay, so we have to put this value in 2 again. Okay, we will get the particular solution. So finally, so equation 2 implies, here we have y is equal x minus 3 to the power 6 is equal minus x minus 3 cos x plus sine x and plus 6. So this is the particular solution. If you are dividing x minus 3 whole power 6, so it would become y is equal, when we divide this factor on the right side, so it would become minus cos x divided by x minus 3 to the power 5. The second one would become sine x divided by x minus 3 whole power 6, and then plus 6 divided by, it is going to be x minus 3 whole power 6. Okay, so this is what we call particular solution.